First Spin. Welcome to First Spin, a show where I learn how to use the Parallax propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of two experts.
Whisker, me.
Hi, Whisker.
And me, Roy.
Hi, me, Roy.
No, just Roy.
What's up, guys? Happy Tuesday.
Tuesday?
Yes, Tuesday.
Well, when they hear this, it'll be Tuesday.
Yes. So everybody, happy Tuesday. It looks like... Huh? What?
Indeed.
Yes. It looks like today we get into the symbols, the unary operators, and if we have time, the binary operators.
Yeah.
Although I think that's a bit ambitious, but
yeah,
we'll see. Were
We'll
you
see.
saying you were dubious about this?
Yeah, I was dubious about us getting to binary operators today.
Okay. Well, I will try to understand efficiently. Quote, as always.
So the first one's pretty easy because it's plus.
Now, is that that's addition, and that's also that it's a positive value?
But in this context, for a unary operator, it just means make it positive if it's not, and if it's a variable. Like if it's a constant, it just doesn't matter because, like, if you have a 5, that's positive. You don't need to say plus 5.
Okay.
But if you have a variable, like, x, then x could contain a negative number.
And if you want to make it positive,
you can say plus in front of it and it'll flop it.
So is that the same thing as like the absolute value of?
That's actually not true. It won't plus it. It actually, I forgot about this little caveat. It actually basically does nothing. You can put it in there for visual, like to indicate it's a positive number instead of a negative number, but it's not really. Plus is basically just ignored.
Oh.
If it's a unary operator plus. When it's one of the other ones that we'll get to here in a little bit, the plus, then it actually does something. Or if it's, x plus y, then it does addition, right? But in the context of being a unary operator, it pretty much does nothing.
Well, then I guess I need to ask what a unary operator is.
A unary operator is an operator that operates on a single operand, a single target thing. So if you just had x by itself, right?
Yeah.
Then if you put a unary operator in front of or after it, it will just operate on x. Whereas a binary operator, you have to have two operands. So you have, two variables for addition or subtraction or multiplication, right? You have to say x times y, x plus y. You don't. Whereas for, negate or plus or any of these other ones that we're about to discuss, they just operate on a single entity, a single thing.
Huh. Okay, so to clarify, if x is negative, then even putting a positive sign in front of that will not do anything.
It just doesn't, plus in front of doesn't do anything.
Okay.
It's the same as if you say plus a negative number, it's still subtraction.
Still negative. Okay. All right.
Negate is a little different because if you put a minus in front of a positive number, it makes it negative.
Well, that's pretty normal too, though.
Right. And then if you put a minus in front of a positive number, it's negative. But if you put minus in front of a negative number, it makes it positive.
Correct.
Because minus a negative number is addition.
Right. Two negatives make a positive. Right.
Right. And that's one of the things that throws me off guard with the whole plus symbol. Like I started out saying, it changes it because the negate does, but in this case, the positive doesn't.
Right. But that's just like basic math. So.
Right.
Okay. All right. So I'll treat it like that.
Right. So then these next two are a little special because they have different meaning depending on if they're before or after. So minus and plus do an increment or a decrement. And in the case of minus, if it's before the variable, so if you have minus x, then it will what they call pre-decrement, which means It'll take the value in X and decrement it by 1, which that's what decrement means. Subtract 1, right? And then that's the value that's in X. And then that's also the value that would be used if you had that as part of a formula. So if you said, A colon equals minus minus X plus 10.
Okay.
And X happened to contain 2.
Okay.
Before you got to that line,
then
it would subtract 1 from X, which would make it 1, and then it would add 10, which would assign 11 into A. You follow me with that?
Nope.
So minus minus is just subtract 1 from whatever the thing is, from the variable, right?
Oh, it means subtract 1.
Right. And it's important, though, whether it's before or after, as to when it does the subtraction.
Okay, so if it's before, then it's as if it had parentheses around that.
Right.
That X, that one operand, I guess.
It's like that, but it's also important to note if it's after, it's called PostDecrement, and what happens in that case is going to be a little bit to explain to you. So back to the same example, if I had A colon equals X minus minus plus 10 after that, space plus 10, it will, and X again contains 2.
Yeah.
What it will do is it will say X equals 2 plus 10, and that gets assigned to A, and then it will subtract 1 from X and assign it into X.
Wow, that's confusing. No, I mean, I get it, but that's confusing.
A different way to think about it. Let's go with a little simpler way. Say you're calling a function and you're passing a variable X into a function.
Yeah.
Right? So you have function, my Addie's function, right? And you pass a parameter into it.
I would call it that too.
So if you called Addie's function and in the parentheses right after you call it, you put in the variable X.
Yeah.
Right? It would just pass whatever happened to be in X into your function.
Correct.
Okay?
Correct.
If you put minus minus X in the parameter to that function, it would first subtract 1 from X and then pass that in. Right?
Okay.
So if X contained a 2, it would first subtract 1 from X, making it 1, and then 1 is what would get passed into your function, into Addie's function.
Okay.
Okay. Now, in the post-decrement case, if you had X minus minus passed in, it would pass in X first, and X contains a 2, so it would pass in 2 to the function. But then it would subtract 1 from X. So X would end up being 1 because it subtracted 1 from the value that was in X. But the value that gets passed into the function is the value of what X was before the subtraction.
Now, okay,
that's what it means by post-decrement versus pre-decrement.
Okay.
The short version of this is that when you're doing a pre, it does the decrement or increment before doing anything else.
Yeah.
When you do it as a post decrement or increment, it does it after it finishes this line of code.
It's not necessarily after the line of code, because you could put parentheses to force it to be scoped, right? So you could say X minus minus in parentheses plus 10, and then it would still do the minus minus before adding 10.
Wow.
But it's a matter of the context that it's in. That's why I said it's going to be hard to get you to understand fully, because it is kind of a rough concept.
This is one of those subtle things that a lot of people get wrong.
Right.
Huh.
So it has to do with so you get the basic idea that minus minus is subtracting 1 from the variable.
Right, yeah, okay, I get that.
In either case, after you get down to like the next line of code, or after you get outside of the parentheses, the variable will be subtracted by 1 if it has a minus minus before or after. And the same thing with if it has a plus plus before or after, it will be incremented by 1. But it's what value gets used in the context of the expression that it's in. And so the expression in this case is, like I was saying with the plus 10. So if you have minus minus x plus 10, the expression is the x variable plus 10. That's the binary expression.
No, it'd be 1 plus 10.
Well, no, I'm saying just in general, whatever the minus minus x, if it were x minus minus, it's still just the variable x minus 10 ultimately.
Okay, so I'm gonna write this on the first spin show notes so we can take a look at this. So if you guys can follow with me, I'm gonna try to figure this out. So a colon equals x minus minus plus 10. X is 2. Okay, so then a would equal 12, and then x would equal 2.
No, x will end up equaling 1 after the expression is done.
Okay, after the expression is done.
Another way to think about it it may be a little, I'm just trying another idea, is if you think about the plus as calling a function with the 2 parameters. Did you get so let's back up one more step. Did you get the thing when I was saying, when we're calling Addie's function and passing in the variable?
Kinda.
And so if you put the minus minus in front, it will do it and then pass it in. And if you put the minus minus afterwards, it will pass it in and then do the minus minus.
Right. Well, that's why I said that it would pass in 2 as x instead of 1.
Right.
But you corrected me.
Well, what I'm saying is pass in 2 as x for the expression of the plus 10. But then at the end, after it did that expression and assigned it to a, then the x would still get the subtraction done to it and end up being 1. So on the next line, if you said, print x, it would print out a 1.
Huh. I thought it would pass in 2 and then do the minus minus.
Right, to x, but not to the expression being assigned to a.
Wow. I don't know, man. this is a little complicated. Okay. Well, okay, let's try.
It's a pretty key concept to get right. You could do a whole lot of programming without using these at all.
Well, yeah,
right, but
if you can do it, it's a pretty neat way of manipulating numbers and such.
Well, it's a shorthand way of doing, x equals x plus 1, right? You can just do plus plus, x plus plus. But it's also has subtle implications depending on the context, which is what we're trying to get here to get you to understand fully.
So then okay, so at the end of these a colon equals whatever, whether post-decrement or pre-decrement, x will equal 1.
Right.
Okay.
After the expression is completed, x will equal 1.
Okay. So then for our equation, x colon equals a colon equals x minus minus plus 10, a will equal 12.
Right.
Okay. But in a colon equals minus minus x plus 10, the pre-decrement, a will equal 11.
Correct. And that's because pre-decrement means it decrements it first and then uses it in the expression.
Okay.
And post-decrement means use the variable
in
first
the expression and then decrement.
And then decrement. Yeah. And the same thing for increment.
I guess that saves an extra step of saying a colon equals x plus 10 and then x minus 1. X equals x minus 1. I guess that saves that.
It shortens it, but there's other uses for it. Like if you could have a repeat loop where you're accessing an array. Say you have an array of 10 letters in an array. You could repeat 10 and then using the variable x, you could say PST, stir, or DEC, my array, right? Open bracket, X plus plus, close bracket.
Okay.
And then it will use X, which if we started it at 0, right?
Mm-hmm.
It would access the first one
Mm-hmm.
and print that number with PST and then increment X
By
all
one.
in one line. And then you would repeat that line and it would go
and
10
just keep
times
incrementing by one.
Right.
Okay, so then...
And accessing the array using the value that was in X.
Okay.
Before you incremented it.
Okay.
But then the next time around through the loop, X is now 1, and it will do the same thing.
I see. So then let's actually go to the plus plus side here. So A colon equals X plus 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 10 would equal A colon equals 2 plus 10. And that'd be 12, and then X would equal 3.
Right.
Okay.
If X started out at 2.
Right. I'm just using the same exact equations as before, just substituting with plus plus. And then the second equation would be A colon equals plus plus X plus 10. That'd be A equals 3 plus 10, which is A equals 13.
Right.
And then X would equal 3.
Right.
Okay. I think I get it. It's easier to visualize it than it is to to talk about it, because otherwise it's just like plus plus A. What in the world?
For me, I've been using it so long that it's sort of built into my mind to think about it the right way. But I get that it's like hard to understand because you're like, well, it's just doing plus plus. Why does it matter when and where and all that? And, and the post and pre kind of thing. A lot of people don't realize that it is important. They just use it. Most people use plus plus and minus minus as just, they'll have a line and they'll say X minus minus or X plus plus. It's just a shorthand for doing X colon equals X plus 1.
Okay.
Right?
Yep.
That's the shorthand plus plus.
So that means when you, like, for instance, if you have a push button that's going through different case states,
right?
Like say my heart LED project where I push one button, I could use these unary operators, the plus plus, to increment the state by 1, correct? In like one line.
Right.
I see.
You could say state plus plus, and then after that line, state would be 1 higher than it was.
I actually might want to do plus plus state instead.
Well, it just depends. It's up to you. It depends on how you wanted to use it.
Right. Well, because my problem in my code was that if I put state in as 0 and then I put state equals state plus 1, I could never get case state 0. Right. It would automatically go to 1. So what I want to do is actually use it
to post increment
and then increment it.
Right. So you would want state plus plus in that case because you want post decrement. So you would say send the state plus plus.
Right.
And then state would be 0 when it sent it, but then it would be incremented after it sent it.
I might be able to fix my code then, because what I ended up doing was I just relabeled the case states so it started from 1 instead of 0. But I think that's a bad coding practice.
I gave you the shorter version of that when we were chatting the other day.
Yes, but you didn't give me this version.
Right. No, I gave you one that you would understand because you were familiar with before we had gotten to this.
Right. Right. But it still didn't give me 0. See?
Right. No, I understand.
Right. So now I can actually fix that code and have it work the way. I mean, not that it didn't work well, because it does, but.
Right. You just had to handle the fact that you didn't get your 0. You started.
Right. I was a little annoyed at first, but I realized it was just the code being the code. So
I think we're making good progress on getting Addie to think of math starting from 0.
Yeah.
Meh.
So the next couple of unary operators are pretty simple. Square root means just take the square root of the variable.
Now, can I ask something?
What
happens if you have I don't know. Like, actually, I guess there's no way you'd end up with a decimal. Never mind. Ignore me.
Yeah.
Continue.
They're whole number. So square root, you just do the little caret twice,
Right.
caret, and then x, right? And if x has 4 in it, then the square root is 2.
Okay.
Now, when you do a square root of, say, like 45, does it just drop the remainder, or does it round?
I believe it just drops it. I'm just double checking that because I was predicting that question.
That's right. Yeah, that's what I meant to ask. I was thinking squares, but it's actually getting the square root.
So if you use it at compile time, you can actually use the square root operator with floating point numbers, and it will do the floating point square root equivalent. But in runtime, it will just do integer. And it looks like it doesn't say much, but it looks like for integer, I think it would just be rounded off.
To
rounded
lower
off or dropped?
Well, it's just integer. It's an integer square root. So I think it would just be the first number below the value that is the actual correct value. Right? The first whole number.
So you could say drop off.
The square root of 45 would be 6, and the 0.7 whatever would get dropped. It wouldn't round it up to 7.
Yeah, I don't think it does any kind of rounding. We'd have to just try it, make a little program. That could be an exercise for Addie to try. Is use square root and print out the results for a series of numbers and see if it does the round down or round up.
I could do that, maybe.
So then the very next one is really simple. It's absolute value.
Mm-hmm. And do you do that in front of your expression?
Oh yeah.
Okay.
These two are in front of. So
okay.
Square root and absolute value is like before the variable or before the expression.
Okay.
Because you could have like square root of y plus 42, and then it would put that in parentheses, and then it would take the square root of the result of y plus 42.
Okay. And then
if you wanted to.
Okay. Right. All right. Yep. Okay. I get it.
And so absolute value is just what it says. It makes negative numbers positive and leaves positive numbers positive.
Mm-hmm. Yep.
So they're just extremely useful.
Yep.
It is extremely useful, but it's also extremely simple.
Yep. Although you could negate it too.
Well, that would be silly because then you're making everything negative instead of...
No. You can negate the negative numbers.
Right, but if you negate a positive number,
it becomes negative.
True.
So negate will flip them. Absolute, you know what you're coming out with.
True.
Right.
Okay. I accept.
So you've used the next two in one form.
Yeah.
The little tilde.
Yeah.
And
so
the tilde.
I think it's if NA equals tilde, single tilde, it's input. No, 0. Sorry.
Right,
0.
It sets it all to 0.
And if DIRA tilde, then it's input, right?
Right.
And then
it's just the simple version. You're actually signing to registers and saying what it does to the actual result. But the simple thing is just that a tilde after the variable or register is setting it to 0.
I see.
And a double tilde after a variable is setting it to -1. And we talked a little bit about this last time with the true and false. So -1 is all the bits on of a 32-bit long.
Right.
So it's equivalent of setting, for your case, dir a. If you did dir a tilde tilde, it would set them all to 1, all the bits to 1.
Is that because...
And that would set them all to output, right?
Okay. Is that because if you were to do it to 1 instead of -1, you could mistake it for like 1,
well, no.
like the actual value 1?
Well, the thing is with 1, it's only the first bit of the 32-bit long is turned on.
Yep.
With -1, they're all on.
Yep.
Okay. It has to do with the complement math.
Yep.
Right?
You pretty much answered my convoluted question. Yeah. Okay.
So the other use for these is if you put it in front of the variable, it does something called sign extending. And this is it's a particular thing to the way computers do integer math with 2's complement binary numbers. So if you had a 7-bit value and So it's like a value from 0 to 127, or negative 127 to positive 127.
Yeah.
Then it's actually negative 128 to positive 127. But then you could use this sign extend on that value to sign extend it into a full 32-bit value.
What is
so if you had just a byte as a variable, and it was the byte you could extend it.
Okay, so say it's like all zeros, right? X is all zeros.
Then it won't do anything, because sign extending is in the integer stuff, the sign bit is the top bit of the variable. So if it's a byte, the top bit, which is bit 7 in this case, is a 1, and that means it's a negative number. And in the double tilde in front one, it does it from bit 15, which is the top bit of a word. So we went over words, bytes, and longs, right? So words are 8 bits from 0 to 7. Bytes are 8 bits from 0 to 7. Words are 8 bits from 0 to 15. And then longs are 32 bits from 0 to 31.
He means that a word is 16, but
right,
all
16.
This is a mouthful.
It's a mouthful. So what these two things in front of the variable allow you to do is to take a variable that you have that's in a byte or a word and copy it into a long and make sure it keeps its value for negative.
Oh, well, you should have just said that in the beginning.
Well, it's kind of it's not just that simple, right? Because it's actually taking. So if you're long, whatever's in the long doesn't matter. It's taking the value that's in the byte, and if it's a negative number, it's making sure it stays negative in the long while it copies it over into it, and it's just extending the sign bit all the way up to the top of the long.
Oh, like the actual positive or negative sign.
Yeah.
Right. Well,
which is one of the bits.
Right. It's the top bit. And so it basically copies that bit, that's the sign bit, into all of the other bits going up above it. Right? So that it extends it all the way up to the size of a long. So if it's a positive number, that top bit will be a 0. So it'll put zeros in all of the other bits up to 31 in a long. Right? And if it's a 1, meaning it's a negative number, then it'll put 1 in all those bits up there.
I see. Okay. So I'm just going to think of it like a copy paste. Because that's just easier to think of it.
It's a copy that keeps it's a copy from a smaller sized variable, a word or a long, or a word or a byte,
into
a long, and keeping the negative number aspect of it. Correct.
Okay.
That's the main thing to think about it.
Got it.
All right. Okay. Excellent timing. Just out of time today, and that's good because the next one is actually going to require some explaining.
The next few, actually.
Yeah. So, any quick questions in general, Addie?
Sorry,
we're done?
Really quick. So that was before, right? The sign extending. But what about post clear, post set?
That was the first one he explained.
That's what we explained already that you've already used. You use those.
Oh, I see.
Like dir with a single tilde equals clear to 0. And,
got it.
Right.
Okay. All right. Well, that's it then. I'm good.
Now you know how the post clear and post set works. It actually goes in and changes all the bits. One of them changes them all to 0. One of them changes them all to 1.
Oh, I see. Epiphany light bulb.
There you go.
Got it. Very cool.
All right. Well, that's all the time we have for this week. Thank you for listening. You can find this show every Tuesday at firstspin.tv. And we're all, of course, on Twitter. You can find the information for that stuff in the about the show.
Yep.
All right. We'll see you guys next week.
Bye.
Bye.
See ya.